NURBS 3D modeling software. Let's see. Okay. Who can tell me what NURBS are? Yes. Good guess. Good guess. Yes. Very good. When in doubt, look at the tutorial. Yeah, so non-uniform rational B-spline. They're mathematically defined curves, and modelers like Maya and Rhino and 3ds Max are NURBS-based modelers. So that's the difference between Rhino and a program like SketchUp, for instance, or AutoCAD. You have much more fluidity and kind of access to curvilinear form and modeling. So it's just much more fluid. But the amazing thing about Rhino as compared to Maya and 3ds Max, as we were saying the other day, is that there is this capability for output, capability to realize and fabricate these curvilinear forms through CNC fabrication processes. The other amazing thing about Rhino is that it connects 2D line work to 3D modeling. So you can take 2D line work that is generated in AutoCAD or some other drafting program and import it to Rhino. So and as we said yesterday, it's also very good at talking to other softwares. So you can import from Illustrator, export to Illustrator, 3ds Max, SketchUp, really any program. And we'll take a look at a list of the file types that Rhino can talk to in a moment. So we are going to open a new file. Maybe I'll start here. Now it takes a moment. Okay. As you were doing the initial tutorials in Rhino, what did you find? How was it moving through it? If those of you who maybe are more familiar with SketchUp or AutoCAD, what seemed clunky to you, or what seemed kind of more intuitive? Yeah. Yeah. Okay, we'll go over that. And what are you used to? CAD? Okay. Okay. Very, very possible in Rhino also. Okay, so we open a new Rhino document, and we're going to choose large object inches. And what that means is it's just you're creating a document, and the units will be inches, and it orients this grid here, or creates a grid that will that's scaled to larger objects. So things kind of more of an architectural scale. If you're working at more of an industrial design scale, you choose small objects inches or millimeters, depending on your unit. So if we want to open a file or import a file, we can see all the different file types that Rhino can speak to. Let's see, file open, all compatible file types, and here's that amazing list. So again, if you're more comfortable with CAD or Illustrator, any of these other programs, bring your documents into Rhino because Rhino can take it. Okay. So there are pretty much 3 ways of doing everything in Rhino, and it's similar to AutoCAD. You can type in the command line. That's my preferred way of working. That and hotkeys, which we'll get into in a second. How many of you know what hotkeys are? What's a hotkey? What was that? Yes, keyboard shortcut. Okay. So in Rhino, those are called aliases. And you can set your aliases to whatever it is you see fit. So we can use the command line, use hotkeys, use the toolbars here, and then there's also the menus, which are up here. So everything is either here, here, or in the command line. And the thing that I love about the command line is the command prompt. So, for instance, I'm going to type in SEL. SEL is the beginning part of the command select. And so you can see all of the different things that you can select. This list is endless. So when you start a crazy file that has a bunch of different components and you just want to select all of the points in the file, or you just want to select all of the curves. In Rhino, lines are referred to as curves. And then the abbreviation for that is CRV, okay? You can just type in SEL and you can select your closed curves, or you can select all of your curves, or you can select a particular color. It's really quite robust. So just to go through the menus first, we have File, which is pretty standard file menu. New, Open, Save, Save Small, Save As, you know the drill. Edit, also pretty standard. But we have Cut, Copy, Delete. Here are all the select tools that we were just talking about. Then there are control points, commands, visibility, so you can hide, show, show selected, lock, unlock. Lock is actually a new command for me, which I'm excited to talk about today. Arrange, which is a similar command that you might know from Adobe Suite. You can bring items forward or push them backwards. Groups, similar to CAD, grouping and ungrouping items. Blocks, a little bit different from blocks in CAD, but usually they come in actually when you import a CAD file or a file from another type of software. Things are blocks. And then the layer menu, which we'll get to in a second, but you can edit your layers through this menu. Join, explode, trim, split, all pretty standard commands. And then we have our view options, so we can change the way that we see things in our interface, and we'll get to that in a second also. The curve menu, again, curve in Rhino is line, okay? Surface, so all of the different tools that you use to create surfaces. Solids, what's the difference between a surface and a solid? It's kind of a tricky one. Yes. Yeah. Yeah. So Rhino is a surface modeler, so you can create surfaces using line work, okay? And that, as you said, is just kind of more of a, I mean, it can be three-dimensional, but it can also just be two-dimensional, right? But a solid is necessarily three-dimensional, and it's a volume, okay? So that's more of how people tend to model in SketchUp, is through solids, extrusions, masses, okay? But we'll look at how to do that in Rhino as well. Mesh. What's a mesh? What's the difference between a mesh surface and a NURBS surface? So a NURBS surface, oh, go ahead, yeah. Yes, yes, very good. Yeah. So a mesh is a surface that's approximated through other flat surfaces, okay? So again, if you bring in a model from SketchUp, it will import into Rhino as a mesh because SketchUp understands things in terms of planes, okay? Rhino understands things in terms of points. So Rhino is just much more fluid and nuanced, I should say. Moving on, dimension, similar to CAD, linear dimension, aligned dimension, rotate. There are leaders here. You can change your text configurations and your hatches. Rhino recently has introduced a lot of drafting capabilities because it was originally created for the industrial design community, but architects have really taken to it, and so they've introduced many more kind of drafting tools. Tools, object snap. So these are similar to CAD, all of your snaps here. You can snap to the end point, a near point, a point, midpoint, center. Let's see. There's these different scripting capabilities, which we won't get into today. And then import and export options. Oh, there's a calculator. That's exciting. And then some analytical tools, which we also won't get into today. Rendering tools, which we'll get to later this week. And these are tools that I have through a plugin that I installed called Paneling Tools. And then the help menu, which I highly, highly encourage you to access. It is actually a pretty incredible help menu. When you access it, you can search a tool. Let's say you're having a lot of trouble with the extrude tool. So we're going to type in extrude. And then it gives you a list of all of these different extrusion tools. And then when you click on one, it has a short video. Several short videos, but it's really, really in-depth information about each one of these tools. So when in doubt, consult the help menu. It's all there. Okay? Okay, so then we have all of the icons up here, which are great also. You can tell that the icons kind of have more information in them, similar to Adobe Suite if there's a little triangle in the lower right-hand corner. So if we click this polyline, for instance, we can maximize that menu, and then these are all of the line tools that we have at our disposal. So there's line, polyline, line for midpoint. The line tools that I typically use are polyline and interpolate curve. Okay. Similarly, we have our kind of our more surface plane tools. So these are all the different ways that you can make surfaces. A rectangular plane from 3 points. There are the extrude tools. So all of the tools that we are looking at up here also exist in these toolbars. And then you can adjust your toolbars if these aren't the tools that you really want to be seeing, or if you want some of these tools to be maximized. You can just right-click in the dead space up in your toolbar menu, and then you can choose the toolbars that you would like to see. Okay? The other way that you can do that besides right-clicking is by typing toolbar in the command line. And look at all of the crazy commands that come up in the command prompt when I just type in tool. So I really encourage you to explore Rhino through the command line because you're going to get introduced to a lot of different tools just through the command prompt. Okay. Questions so far? How's the pace? Good? Okay. Let me know if I'm going too slow, too fast. Yeah. Okay. So moving around the Rhino interface. So this is a tricky thing. I know that when I was learning Rhino, I kept on finding myself upside down. I couldn't pan, I couldn't orbit. Selection tools. It's a funny thing how these very, very basic pieces can trip you up. So I'll try to go through this quickly, but basically to pan or to orbit, a really useful tool, you right-click. To pan, you hold down Shift and right-click. To zoom, you just use your scroll. Okay? And there are a lot of really great zoom tools. So I'm just going to create some really quick objects to just illustrate the zoom tools. So many times your Rhino file starts to get kind of heavy and overloaded, and it's hard to orient yourself within the file. So one of my favorite tools, and I'm sure will be one of your favorite tools also, is Zoom Selected. So if you type in zoom, there's a second command that comes up with zoom, and you can zoom all, dynamic, extents, factor in, out, or zoom selected. I have one of my little boxes selected right now. Zoom selected, it brings me right there. And now when I orbit, it orbits around this object because that's in the center of my field. Okay? Mm-hmm. Yeah. And the shortcut is ZS. I don't think I programmed that. Does ZS work for you guys? Okay, great. Cool. I always forget what aliases I've made and what are come with the program. Okay, and then the viewports are also a really important piece for navigation. So up here in the upper left-hand corner, you'll often be accessing this menu here. If you click the little arrow next to perspective, you'll see a whole menu of different options for viewing your interface. So right now we're in wireframe mode. We can change to shaded mode. So shaded mode is just kind of like a blocky representation, slightly shaded. There's a small sheen on your objects. We can also go to rendered mode. Ooh. Rendered, not awesome, but if you're applying materials to your objects, you can kind of get somewhat of an idea of how the seams are working in the material or the direction of the wood grain or things like that. Ghosted is actually my preferred view style, and this is where you can see slightly through the object, but it also you get like a pretty good sense of its shell. Whereas X-ray, you can see through the object completely, and sometimes it's hard to get a sense of what's inside and what's outside. And then we have these others that I never really use, which are technical, artistic. Oh, look at that. Amazing. And then you can also create your own styles for viewing, and we'll get into that a little bit later. We can also set our views. So right now we're in perspective view. So if we just double click on perspective, it will bring us to a four viewport. I'm going to change this to ghosted. And we're in the top view, in the upper left, in the right view, and then in the front view, we're here. So kind of like plan, elevation, and section, okay, or a different elevation. Does that make sense to everyone? And then to maximize any of these views, you can just double click on that viewport. Okay? Cool? Great. Let's see if I missed anything else in here. You can change, well, this is kind of more advanced, but you can change the viewport properties. Actually, I'm not going to do that right now. Let's see. Another thing that we'll get into a little bit later in the set view menu is kind of saving views. So once you start to think about outputting your work, you can save a view in the set view. So if we go to named views, and let's say this is our preferred kind of rendering shot, we can save this view as view 1. And then as we move through space, let's go to perspective view. We're modeling, we're adjusting things here and there. We can go back to set view, named views, and that view 1 is saved. You can select it again, and it'll bring us right back to that same view that we had saved. Okay? And then you can output in a number of ways. We'll get to that in a later tutorial. Okay, so another really important kind of setup zone for Rhino is document properties. How do we get to document properties? Can anyone venture a guess? It's my favorite way of doing things, the command line. So if we just type in document properties, it will bring it up. And this is a really important piece of Rhino. I like to call this the golden center of Rhino. And you can go through each one of these fields and pretty much change anything about how it is you're experiencing the program. Okay, so annotation, for instance. The default annotation style for Rhino is always super big and clunky. So here you can go into dimensions, go into your default dimension, and you can change it from decimal to feet and inches. You can change the text height. You can change the text gap. You can change the precision of the dimension. Okay. Same thing with hatch. You can choose which hatches you have access to, or you can import hatches. Okay. So really, Rhino has the capabilities of a drafting program. You just have to set it up and then and kind of understand it, and then you can do just what it is you would do in AutoCAD. Okay. Here you can adjust your grid settings. So grid line count. I don't really use the grid. I don't know many people who do, but sometimes it's a good kind of scale measure just to understand what an inch is in your document. So right now our grid is happening, oops, I'm in millimeters. How did that happen? I thought I chose large objects, inches. Let's change. So we'll go into units to change that. So if you find yourself in a millimeters document, you can select units and then drag down to inches and then feet in inches. And for most of the work I do, an eighth of an inch precision works. Okay? Yeah. Yeah. Okay, so then we can go into, let's see, there's line types, grid, mesh, I don't think we need to talk about. Rendering, we're not getting to now. Units, and then aliases, really awesome menu to adjust if you're used to other drafting programs or modeling programs. So here you can set your tool hotkeys, okay? So if you want to make a new one, you just press new here. And let's say I want Polyline to be PL. Then I can just type in Polyline. And you can do this for all of your commands. And it's really quite forgiving. There's no it's not case sensitive, or there's no like kind of strange syntax that's needed. Let's see, what else? What's another command that I like? I like R3 for rotate 3D. I'll just leave it at that right now. And then appearance, this is where you can change anything about your interface. So you can change the background color, the text color, hover color. I have always just kept all of mine at default because I like the gray screen. But anything that you want to change about your appearance, you can do here. And then here this is the background color and then the grid colors. And then the rest of these, I don't really, you can adjust your toolbars here also, and view. Yeah, the rest of these I don't use as much. You can set hotkeys here also on your keyboard. So you can set F4 to be ortho, for instance, or what does ortho mean? For those of you who use CAD, why would you want something to be ortho? Yeah. Yes. Yeah, so any line that you draw will either be moving in the X or the Y direction, okay? Or the Z direction in Rhino. Many times people are wanting to kind of get into ortho mode quickly. I typically just click down here, and then here are all of your object snaps also. Or you can type O, I think is the hotkey, but I prefer O for offset. Any questions so far? Yeah. Yeah, that's in the aliases. So right here. So what's a command that you use often? Extrude, and what's the hotkey? Oh. Oh, okay. So let's make extrude EX. So we can just type in EX, so that's the alias. You can see in the left-hand column here, EX, and then we just type in extrude here, and then if we hit OK, we can now type in EX, and you'll notice that the extrude command comes up. Or another one that I set was rotate 3D R3, R3, select objects, oops, not 3D, R3. Select objects to rotate. What do you mean? Oh, rather than import them or something?
I'll upload my Rhinoceros file to log and the page off
I wonder, I've never imported, oh yeah, you can import here. So it looks like you're looking for a .txt file. So if you can figure out how to export a txt file from CAD with your aliases, then you can import it here. I'm sure that's, if you Google search it, I'm sure it would be easy to figure out. But Rhino, I mean, that's the amazing thing about Rhino. It wants to talk to other softwares. It's not my way or the highway. It's let's collaborate, right? Okay. Yeah, or type that letter. Yeah. 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 Yeah, it depends on what you prefer. I always have one hand on the keyboard and one hand on my mouse. But yeah. So let's see, moving on. Okay, so now we will go to properties. So you'll notice here on the right-hand side, another really important kind of menu spot. This is document properties. So if we select these 4 or 3 rectangles that I just made, it will tell us what they are. It will tell us what they are in terms of what type of geometry they are. They're 3 closed extrusions. It'll tell us what layer it's on. It's on the default layer. It's being displayed by layer. And that's all we really need to know about this object, but it also identifies light. It identifies whether a surface is open or closed, whether a curve is open or closed. It's a really valuable menu when you get kind of a more complicated file and are trying to sort things out. And then you can just toggle over to layers, and it will show our default layer here. You can create new layers by hitting this little page icon, like so, and then you can rename your layer. I'm going to call this layer surfaces. Okay, and then you can turn your layer on and off by clicking this little light bulb. You can lock your layer, which means similar to CAD or Adobe Suite. You just can't really modify it anymore within your document. And then you can change your layer color here. And then if you click this little circle next to the layer color, that's where you change the material properties. And you can do that in a very simple kind of Rhino render sort of way, or you can do it in a V-Ray sort of way, which we'll get into in a later tutorial. Okay. Let's see. And then the help menu is also located here. So rather than having to go up to this menu, you can access the help menu and answer any questions that you might have on the right-hand side. And then you can also adjust how it is you're seeing things in the display menu. Okay. Let's say we want to change objects layer. We can just select our objects and then right-click on the layer, and then a whole another menu of options comes up. We can change object layer, pull down to change object layer, and notice now they've changed from black to red. They've moved from default to surfaces layer. And I'm going to move to my ghosted color, and rather than view one perspective. Okay? Does that seem pretty intuitive to everyone? So the layer menu is really quite extensive once you start getting into it. You can pretty much right-click on anything and get more information about it. Okay. Okay. So selection. We already talked about zoom selected. Awesome tool. Like CAD, you can select, when you select from left to right, you only select what's within your selection box. When you select from right to left, it's anything that crosses your selection box. Okay? So notice how when I only, I should get these closer together. Okay, so when I select from left or right to left, anything that my selection box touches is selected. When I select from left to right, notice how the selection box is, rather than dashed, it's solid. nothing selects when I cross it. I have to fully envelop it with my selection box in order to select it. Okay? And then to deselect, this is a command that I learned way late in the game, which is strange. You hold down Control. Okay? And then you can deselect things. So select and deselect. Yeah, so when you have a bunch of items selected and you want to deselect just a couple, you hold down Control, and then you click on them and deselect them. Okay? Okay. And then Shift, like many other softwares, you can do multiple select. Okay? So if you are not holding down Shift, you'll just select whatever it is you click on, but if you hold down Shift, you can do multiple select. Okay? Does that make sense? Yeah, okay, good. The nods are awesome, by the way. Okay, so we'll do a quick, a really great way, I think, to create in Rhino, to make in Rhino, is through lofting. It's also very easily out of control. A lot of students kind of, I don't want to say abuse, but misuse the loft command and create geometries that are just kind of not really, I'm trying to think of the right way to say it other than not in control. What'd you say? Unbuildable. Yeah, very good. So be wary with this loft tool, but also it's very powerful once you kind of rein it in and understand how to use it correctly. Okay. So we're gonna go. We have a surfaces layer. Let's make a new layer and call it curves. And we'll navigate to that layer. I'm going to change the layer color. And I'm going to type in interpolate curve. So I'm just going to type in INTER and then interp curve pops up. Okay? And then I'm just going to draw some curves. We're going to make a very uncontrolled lofted surface. Interpolate curve. So right now we're just drawing, in the perspective view, but kind of looking down. And so our curves will be flat, like this. And then when we select these curves and we go into the right view, oh, it looks like so this is a good lesson. It looks like my C-plane is confused right now. What happens when what's your C-plane, first of all? C-plane is this plane right here. And you'll notice that when I look down at my axis right here, my X direction is up, my Y direction is where the X direction should be, and my Z direction is where my Y direction should be. You see that? So how do I fix this? How do I fix this? The C-plane. That's so basic. The C-plane. What do? I type in C-plane in the command line. Okay. And we are just going to put the Z. Let's see. C-plane origin. Let's see. 3 point. Then I'm going to go in the top view. And set it where it's supposed to be. Okay? So now you can see my Z is up, my Y, I think my Y is in the right spot. Let's see. Yeah. Okay, so did everyone see that? Should I do that again? Okay, so I'm going to type in, here I'll undo. Oh, it's not going back. I'll type in C-plane, and I'm going to choose 3-point. Okay, and 3-point means that 3-point is actually a way that Rhino describes a process in a lot of commands, and it's dragging out 3 different points. So first I'm specifying where all the axes meet, this center point you can see. And then I'm specifying where the x-axis is, the red line. And then I'm specifying where the y-axis is. Okay? Okay, so we'll type in interp curve again. Let's draw those curves again. Okay, so in perspective view, let's see, let's set view, and we go to the top. The top view, curves look like this. And then in the right view, looks like my C-plane is doing that again. I actually don't know what that's about, but yeah. Okay, yeah, I know that, but what's happening with my project right now is that the C-plane seems to be moving around for no reason. I'll have to get back to you on that one. But so we're just going to look at, in the front view, you can see our curves are flat. And then if we go to the right view, our curves, let's see. If this happens to you and you have created curves that you expect to be flat, but they're slightly off kilter, the way that you can flatten them in a view and make sure that they're not moving in the z direction is by typing set point. Okay, S-E-T-P-T, set point. And then you are going to deselect X and Y, and you're just going to set it in the z direction, and then it will flatten your curves. Okay? And why my C-plane is doing this, no one knows, unless someone does. It would be great, as we're moving through all of these tutorials, if you guys chime in with any sort of feedback you have, because we'd love any feedback or any kind of workflow advice that you have about any of these processes. Okay, so we'll go back to perspective view. And I'm going to turn my points on because I just want these curves to be moving a little bit more in 3 dimensions. Right now they're just moving in 2 dimensions. So I'm going to type in points and then scroll down to points on. And then we see that we have 2 points here. I'm just going to pick those up. And I'm going to type in move, M-O-V-E, and I'm going to type V for vertical. And then when I hover over my point, I'm noticing that it's not snapping. What does that mean? My point snap isn't on. So I'm going to go down here to the OSnap menu. And then yeah, my C-plane is not treating me very well. Let's see, I'm going to do this again. There we go. Okay, so move vertical. So when I specify moving in the vertical direction, which is actually quite useful because Rhino sometimes can't interpret which way is up, So move in the command line and then V for vertical. And then I'm just moving in this direction. And if I want to specify the distance that I'm moving to, I can just type in, let's say, 20 feet. Okay? And then enter. And escape to turn the points off. Okay? Now that was a little bit further than I wanted to move it, so I'm going to scale 1D. To bring it back down. Okay, so there are my curves. And now I'm going to navigate to the surfaces layer, select my curves, and type in loft. Okay, so loft, what is loft? You just demonstrated it there a little bit. What am I doing? I'm lofting. I'm creating a surface between curves. Okay, I'm using curves to create a surface. And we can choose how it is that we're lofting. Right now, it's just a normal loft. Rhino's just looking at these two curves and creating a surface between them in the way that Rhino understands those curves. But then we can also choose loose. And loose is the way that Rhino kind of simplifies the surface, takes only some of the information to create a surface that's maybe a little bit cleaner, but not quite as exact. So we can preview that. And you'll notice that loose and normal, well, actually this isn't maybe the best example, but many times when you choose loose, you'll get fewer isocurves. So what are isocurves? Fewer isocurves defining your surface. So isocurves are these lines here, and isocurves are defined by U and V coordinates. Okay, so rather than X, Y, and Z coordinates, which define maybe a box in the Cartesian field, U and V define a surface direction. So this is U or V, and then this is U or V. Find out kind of decide for you which direction is U and which direction is V. So when you start to build and rebuild and loft and sweep different geometries, U and V become much more important to understand. So we can also loft as straight sections. See, doesn't seem to be, or developable. Okay, so straight sections looks very similar, but typically it's kind of a more tessellated surface. What does tessellated mean? What does tessellated mean? Yeah. Yes. So a series of planes, kind of how we were talking about a mesh surface. It's a surface defined by a series of planes. And then developable, what does developable mean? So that is a surface, when you loft a developable surface, this is a surface that could be output and into a CNC machine and built. Okay, so it will not generate any sort of doubly curved or self-intersecting surfaces. It's only things that can be realized in real space. Okay, and then you can also choose to rebuild your loft. So you can rebuild with 10 control points. See what that looks like. Well, it looks like there is some self-intersection here between these two curves. Or let's rebuild with 3 control points. See how simplified that surface becomes. Okay. Any questions so far? So it makes more sense to loft with kind of complicated geometries, or curvilinear, not necessarily curvilinear geometries, but many times those end up being more complicated than orthogonal geometries. I think for the next exercise, it won't be necessary that we loft, but if you kind of want to get used to that workflow, you can use that instead of extrude just as easily. Okay? So we just kind of had a quick intro to surfaces and surfaces. Now let's look at solids. So this is the solids menu right here. So you can either pull this out to create solids, or you can type in any sort of solid that you want to create into the command line. So let's say I want to make a sphere. You can choose many different, you type sphere into the command line, and then you can choose many different kind of modes of making that sphere. 2-point, 3-point, around a curve, 4-point. Let's try 2-point, okay? So I'm going to make a new layer and call it solids. Okay. Let's do that one again. Sphere, 2-point, start of diameter. So we're starting on the outside edge of the sphere, and then we're pulling out to define the diameter. And because it's a sphere, that will be uniform all the way around. Okay, so let's try sphere 3-point. And see how that varies. So first point, second point, and third point. So you're kind of making a tangent connection. Does that make sense? And then you can make any of these other. I'll make a new layer. I'll call it cone. Let's see. I'm going to change that layer color also. I'm going to make another layer, and I'm going to call it intersect. Okay. So right now we have a sphere, a cone, and a couple other spheres. I'm going to zoom selected so I can get back in that zone. And we want to understand this relationship between the sphere and the cone. Okay. One way we can do that. So let's look at it. We have an intersection here. One way we can do that is by typing intersect. Intersect. And then it will give us a curve where those two geometries meet. Okay? Why would you want a curve where those two geometries meet? It's hard to say. Many times it's hard, not really with solids, but with polysurfaces or surfaces that you create to edit them with one another. So what I mean by that is trim, split, mostly trim and split actually. And so when you intersect, you create a curve that defines that relationship, and then you can use that curve to edit either one of the geometries that are intersecting. Okay. Another way that you can kind of look at that relationship between the cone and the sphere is through the Boolean tools. Boolean tools are very finicky, and I don't really recommend using them often or getting comfortable with them, but for solids modeling, they're great. So we're going to type in Boolean to objects, and I love Boolean to objects. There are several different Boolean commands, but Boolean to objects, you can kind of just rotate through all of the different Boolean tools. So select to objects to Boolean. When you don't know what's going on, just check out the command line. It's telling you what to do. So we're going to select our cone. We're going to select our sphere, and you can't really see it very well, but we're right now Booleaning out the difference between these geometries. Okay. And then look at the command line. It's telling you what to do. Click through iterations. We click again, and we can get now that what was a void is now a solid. The connection between those two. And now it's the sphere subtracted from the cone. And now it's the cone subtracted from the sphere. Okay? And then you can just cycle through. I think that's my favorite. And then once you have the one that you like, you just press enter, and you'll get your geometry. Okay? Any questions on that, or you need to repeat? Yeah, okay. So repeat from intersect or Boolean tools, or the iterations, yeah. So we are going to select, or we first type in Boolean to objects, and then we're going to select the objects that we want to Boolean, and then you just click to iterate through. So I'm clicking, and then you can get your different results. Other questions? Good one. Okay. So let's create, let's check out the sweep tool quickly, which might be good for making mullions or railings, banisters, things like that, that you might want to model in your buildings, okay? So let's go into the top view. So double click perspective, go into top view. And we are going to type in Polyline. I made a hotkey for Polyline, so I'm just going to type in PL. There we go. And notice how right now I have orthogonal selected. And so as I use the Polyline tool, it's only moving in the orthogonal direction. If I unclick orthogonal down here, and I type in Polyline, unclick orthogonal, now I can move in any direction, okay? So this is Polyline, a series of straight sections of a curve. Interpolate curve, what we were using earlier, is more freeform, okay? I find that to make controlled geometry, curvature that is both straight and curved works well. Okay, so taking your orthogonal geometry right here and filleting it. How many of you know the fillet tool? Many times people use it as a join tool. If you create your radius or select a 0 radius within the tool. So we're going to just type in fillet, F-I-L-L-E-T, not to be confused with fillet. And our radius is 1 right now. So we're going to select the lines that we want to round the edge connection between, round the corner. Let's try that again. Let's change the radius to 6. Okay. So notice how in this curve we're getting curvature in this line, but it's much more controlled than this interpolated curve. Another way that people talk about interpolated curves in other programs or in geometry is a spline. Okay. So let's take this interpolated curve and rotate it 3D. So I'm going to type in rotate 3D. And I'm going to move out of the top dimension and go to the perspective. And I just want to flip it up. I just want to rotate like this. But Rhino doesn't know which way is which, and so when you're in 3D, and so rotate 3D is how you tell Rhino which way you want to rotate. So with rotate 3D, you're kind of making a hinge. So first you specify the axis that you're rotating around, and then you specify kind of the handle that you're rotating around that hinge. So we want to flip this up. We want to flip this up like this into the Z direction. So we're first going to create the hinge, the axis that we're rotating around, and then we're going to rotate up. Does that make sense? So you click once along the axis around which you want to rotate, and then once in the direction for the handle that you want to pull around that hinge point. Okay, and then at the end of this, I'm going to create a rectangle. And I want some kind of controlled curvature. So I'm going to do the same thing that I did with this last. So rather than a radius of 6, I'm going to say radius 3. Oh, that's a little too big. Let's see. Oh, yeah, so I type in fillet, and then all of these commands up here you can either click or you can type in R for radius. So I'll type in R. Then I'm going to change the radius to 1. It might be that you have different snaps selected than I do. Right now I have end and point selected right down here. And do you have this menu at the bottom? Yeah, so that's where you can set your snaps. So I would suggest selecting maybe mid and end. And then you can connect the midpoint of your rectangle to the end of your line. Other questions? Okay, I'm going to rotate this again, 3D. And then I'm going to copy it to the other end of the line and scale it. Okay, so this is what I'm looking here. Maybe I'll move this out of this jumbled mess so that you can see what I'm working on. Okay. So I just noticed that I'm on the wrong layer. I want to be on my curves layer. So how do I do that? I go into my layer menu, right click on the layer, and then pull down to change object layer. Okay. Is everyone with me? Yeah? Okay. So now I'm going to sweep this. I want to make a geometry, a tube geometry. Let's say that this is a tapered banister, okay? Or maybe an underground tunnel in the Schmid artist loft. So we want to create this kind of tapered tunnel banister geometry. So I'm going to type in sweep 1. select rail, select cross-section curves, and oops, I'm not on the right layer. I'm going to go to my surfaces layer, which you can do while you're still in the command. Press enter, and now it's asking me drag seam point to adjust. What does that mean? What's a seam point? Yeah. Yeah. What did I do? Oh, sweep one. Yeah, so you select your, so we're going to type in sweep one, and then we're going to select our rail, which is the long skinny piece, and then it's asking us to select our cross-section curves, which are the two curves on the end. Press enter, and now it's asking us to drag the seam point to adjust. Okay, so right now Rhino is looking at, it's basically a loft between the two cross-section curves, this frame and the other frame here, using the rail as a guide, okay? And because both frames are closed, which is necessary in both lofts and sweep, whatever it is you're lofting either needs to be opened or closed. These are closed because they self-intersect, they connect themselves. Open curves are just open on either end, okay? So it's asking us to adjust the curve seam. Because they're closed curves, it's going to be a closed surface. And Rhino is asking us where the surface will close in on itself again. And so if the curves are happening in the same point of each frame geometry, it'll be easier for Rhino to understand, rather than the curve seam needing to kind of like wrap around the same geometry to begin with. So right now you can see that one curve seam is happening at the bottom of the fillet here, and the other one is happening at the bottom of this other fillet here. So we're going to want to move this curve seam here. And then once our curve seams are all lined up, we press enter. I can't see this very well, so I'm going to change it to a shaded, or to a ghosted view. And I'm getting some kind of crazy self-intersection. You can see these, the fillet radius is a little too tight for Rhino to understand. So let's rebuild it. We're going to lose some of our precision, but I just want to see if I can get something that's a better geometry. Yeah. Yeah, of course. Stop me whenever. Yeah. Okay, so we're just going to type in, so we'll go back to our curve layer, and we're going to type in rectangle, R-E-C-T, rectangle. And we'll just create a box like so. I'll just erase these two. Then we'll move the box here. And then we want to fillet the corners again. So F-I-L-L-E-T. The radius of 1. Then we're going to rotate 3D. Again, it's kind of a weird command to get used to because the hinge axis rotation is a strange idea, but you're just going to select the objects to rotate, press enter, select the axis of rotation, and then rotate around that axis. Yeah. No, you should use it. I don't use it because it was developed recently, and I learned Rhino 5 or 6 years ago. So you should absolutely use it. Yeah. The Gumball? The Gumball is a navigation device. It's brilliant. Yeah, I should get into it. Do you want to explain it, Elliot? Because I don't really use it.
Easy way to kind of
Do you want to?
move objects around on
Can you
the screen.
can you show it up here?
Well, I haven't gotten into it enough to kind of be precise with it, but I use it to kind of just push and pull things around the screen without editing the geometry. So if you select an object with Gumball enabled down in this lower toolbar, it gives you options to kind of rotate it in the X, Y, or Z direction, or move it in the X, Y, Z direction, or scale. So the long arrows are moving, so I want to push this object around. I guess this is what I use the most for when I'm kind of organizing my laser cutting file. I select the Gumball and then I kind of push things around this way.
I think I was first in 3ds Max. Or that's where I first did.
Yeah, it's similar to that. I think this is the best implementation that I've used.
Yeah.
But yeah, so you can rotate in one direction. I think you can move it in like more than one direction. But basically, you click on the arrow, push it around. These little blue and green icons, you can scale in that direction. And wait, what are we in inches?
Yeah.
So if you pull that, and what if we typed in 10 inches? No, it didn't work. Okay. Okay. Oh yeah, like right there. So then we can do. Yeah. Okay. So it helps with navigation. I think it speeds things up a little bit.
Yeah, it's great. And so old school. Awesome. I am, yes. Okay. So is everyone with me? Yeah. Yeah, so that's, I'm pretty sure that's a matter of snaps. So all of the snaps are down here at the bottom. So you have end, near, point, mid. And right now I have mid and point and end selected. So that's kind of telling Rhino what you're going to snap to and then snap that geometry to another. It's like a selection tool. So you select your geometry and then you're going to move it and you're going to you can choose the midpoint of any one of these sides and then move it to the end point of your line. Yeah. Other questions? Good questions. Okay, so now let's go to our surfaces layer, and we're going to type in sweep 1. We're going to select our rail, and then select our cross-section curves, and press enter. Yeah, so the rail is kind of the curvature that defines the direction that these two geometries will connect in terms of surface. So right now it's basically like we're lofting this profile and this profile along this line. So rail is this, and then the cross-section is this. Other question? Okay, so sweep 1, select rail, select cross-section curves, enter. And then our curve seams are pretty close this time around, but not quite in the same spot. So we're going to adjust them so they're happening in the same spot along the cross-section curves. And then we're going to press enter. And we're getting a pretty crazy geometry, right? So let's try to rebuild it. That's looking a little bit better. But really what I'm realizing is that the radii are too tight. Here, here, and here. You can see the self-intersection. You can see the self-intersection happening here and here. So rather than rebuilding it within the Q tool, really what I could do is rebuild these radii so they're left tight. Okay, because then Rhino can easily just stay along this scale in order to go with.
Another thing to think about when doing the process that's not very evident grasshoppers is the normal of the two shapes that you're locked in those two have to match up. It kind of looks like that rectangle on the left is twisting or like the first bend. But then should match up with the rectangle on the right.
Mm-hmm.
So if those normals are in the same direction, all those sides have
Yeah, and a way that we can control this further is by putting additional frames along this rail. So you can, what was that? Just copy. So, good question. So I'm going to type in copy, select objects to copy, enter, and then I'm selecting at midpoint. Okay. And then we can also, it's clear that between this form and this form, we're changing scale, right? And we could even be changing orientation, as Elliot was saying. So these two frames or profile curves don't recognize the change in scale that would happen along the scale. So what we would do to accommodate that is a command called Tween Curves. If any of you have used the blend tool in Illustrator, this is kind of the Rhino version of the blend tool. Okay. So if we type in Tween Curves, you can select a start curve and an end curve. Ooh, and it'll give you a really crazy curve, such as this. I don't know why it's doing that. Let's see if we can. Let's try that again. Huh. There we go. It's not the best example. Sorry, what? Yeah. Let's see.
So if you look at, so this point on this shape is corresponding to this point on this shape. So when she locked it, this one started its rotation along the path to eventually end up at this point.
Yeah. Yeah. So that's a good. Let's try. And we are getting a little bit of strange geometry between these two. But if we kind of accept this rotation within these, or we can rebuild these with new normals. But I think that's getting a little bit too advanced for this tutorial. But you get the idea of sweep. Yeah. Yeah. Yes. Yeah, so that is getting into Grasshopper, or you can also turn on the history. So history actually only works with a handful of commands, and I think it might be a little too advanced for this tutorial, but I can get into it later. Yeah. Yeah, so sweep is only a surface command, but you can either extrude the surface afterwards, or you could offset the surface with a cap, or you could thin the surface. There are a lot of different ways of giving material thickness, but that's a really good question. Other questions? Okay. I think we've been going for an hour and a half now. You guys probably need a little break. So why don't we take a 15-minute break, get a coffee, and then we will start with part 2.